Hello everyone, welcome back. So in this video, we are going to understand the lead code problem number 1895, a largest magic square we have to find in this problem. So this problem looks easy until you are able to solve the problem or solution times out. Okay. So today we are going to solve lead code problem number 1895. It's the largest magic square, classical magic square, we can say. It's a kind of matrix plus prefix sum. So if you are aware with the matrix and the prefix sum, so it will be easy to understand this type of problem. The problem that interviewer mostly loves to ask the questions in the product based companies. So let's try to understand. So I'll explain it in a very simple language, and I'll go through the intuition and the step by step learning, so you can confidently solve and explain it in an interview easily. Okay, so let's try to understand how to implement it. The very first I will say is that you have given this matrix to the grid of integers. Magic square is a square submatrix where every row, as you can see, this red color marked submatrix, where every row has the same sum and every column has the same sum. Both diagonals have the same sum. It means either you are going with the every row, every column, and both diagonals, right, have the same sum. So your task is to return the size of the largest magic square in the grid, even a single cell count as a magic square. So the minimum answer is 1. Understand? So this is what we have to say, that there is always a value that is nothing but is 1. If the size of the magic square is single or unit cell, right, still the answer is 1. Otherwise there will be some size where we will return the grid size, right? So you can pause this video and you can go through. So let's try to understand. Let's say we have find a 3 cross 3 submatrix or square inside the grid. So if the rows and columns and both diagonals are having the same sum, means equal, then we can say congratulations, the square is a magic, and our goal is not to count them all but to find the largest one. Okay, so why this approach will not work if we are going with the brute force to try all the possible squares. So the naive approach is, if you're trying to find the square, you can try every possible square, right? You will recalculate row, column, diagonal sums every time, but that leads to nested loops inside nested loops, we can say a nested loop inside a nested loops. The worst case, the time complexity will become O of n to the 5, because there is a grid and you have to go through every row, every column, and the two diagonals we have, right? So that gives you the TLE. Now we have given things that you can say we have given to the grid a magic square. What is a magic square, that we have already talked about, and what is our task, right? So if there is no magic square, means we have to return 1, because there is always a one answer. So let's take a typical example that is called example grid. This one we have given, and inside this there exists a 3 cross 3 matrix, as you can see in the red color, or you can say 516, 543, 273. So all rows, all columns and diagonals sum up to 12. If you do the sum, 516 is 12, 552 is 6, and as 12, and 543 is 12. So all rows, columns and diagonals sum to 18. For example, this is another grid where we can see that all the rows, all the columns, and all those two diagonals having the same value, that is 18. So think of this as a sliding square window over the grid. So in the very first step, start with the largest possible size. If the grid is m cross n, max square size is equal to, we'll take the mean of m and n, because if we have a grid m cross n, so maximum square size will be the minimum value of the this, because if we'll take the maximum one, that definitely you will not get the square. So step two, we'll slide over the square, and for each possible top to left corner, right, we'll try to find the square with the size, and if it is magic, we'll keep it track. Okay, and then we'll reduce the size if not found. Otherwise, try k minus 1, keep reducing the size 1. Like that, you will find one day a magic square, and you will have tracked the magic square. Otherwise, you will keep with the 3 and you will track another one. So idea is that square is magic if we know row, column, and diagonals have the same sum. So we try avoid the repeatedly. So we use prefix sum for the rows, columns, and diagonals. So try prefix we will bring the prefix sums and we'll try square sizes from the largest to the smallest, and then we'll select a square and we'll get in O of k per square, and we'll return it immediately. So very first we have given grid, and for the as you know, then we will calculate the prefix sum for the rows, column, diagonal 1, diagonal 2, we'll calculate. Then we will build the prefix sum using the I and j. So we'll iterate over the rows, columns, diagonal 1, diagonal 2. And then we'll try the target. So you have to go with sizes, and we know the n, take the size m and n, and so that we can have a square size, right? So we'll check the square size is magic or not. So we'll start from r is equal to 0, and we'll keep moving to r plus size, and we'll try all the possible. So we'll very first we'll find the target. So this target is magic or not. We will check the rows very first, and then we have what is column, and then we have diagonal. So we have the target, magic will mark is at true, and then we'll go through checking the rows, column, and diagonal. All this should be equal, means its value should be equal. So the sum should be equal to target. If it is not equal to target, so in all the cases you will return false if it is not equal. Otherwise, in the finally we'll check the diagonal and diagonal 2, and then we'll check with the magic. If the magic is this and both diagonal is equal to target, we'll return the size, and we'll say okay, this is the magic square, and return the size. Otherwise, if we are not going in these loops, means any of this will say it is not equal, it means it is not a square, and then we'll come to a return minus, not minus 1, it's 1, because the only one cell will be there, that will be also a square, so that you will return, guys. Okay, so this is what we have in this video, guys. So the prefix sum all becomes is one of loop, because we have taken the arrays, rows, column, diagonal, and we have pre-calculated, and the purpose is that for the row wise, column is column wise, and two diagonals we have for the main diagonal, anti diagonals. Okay, so the time is space complexity is, in the worst case you will take O of n to the 4, because if the size in the position into row called check will do, so in the worst case it will happen. Otherwise, it's fast enough for the constant, and for the space O of m cross n will use. So thank you for watching this video, and please make sure that you will like this video and you will subscribe if you are new at Expert Funda. Thank you so much, and please keep watching Expert Funda and support Expert Funda. Without your support, it will not grow. So